Hi everyone, welcome to the third lesson of current electricity. In the previous lesson, we derived the relation between electric current and drift velocity. Today, we are going to deduce Ohm's law from the expression for current. Deduction of Ohm's law. So we got the equation for current in terms of drift velocity. I equals NEAVD. And you know the equation for drift velocity. EV by ML into tau. V is the potential difference. Put in this equation. I is equal to NEA. Instead of VD, EV by ML into tau. I equals N E square A V by ML into tau. So we rearrange it. V by I is ML divided by N E square A tau. See the right hand side of the equation for a given conductor M, L, N, E square A tau all are constant at a temperature. For a given material, N, E, A, M, L, and tau all are constant at a particular temperature. Relaxation time is also constant for a given temperature. So we got V by I equals constant at a constant temperature. This is Ohm's law. V is proportional to I. So we have deduced Ohm's law. And see the equation for resistance. The right hand side V by I, this is equal to resistance. So what is the resistance equation? R equals M by N E square tau, and writing in this way, into L divided by A. So resistance is M by N E square tau into L by A. You know this equation, R equals rho into L by A. Rho is known as the resistivity. So compare these two equations. On comparison, we can say instead of rho, what we can write? Rho as M by N E square tau. So this is the equation for resistivity. So resistivity depends on N. N depends on the nature of the material. Number density of free electrons. N is known as number of electrons per unit volume. Okay. It also depends on relaxation time. Relaxation time depends on temperature. So this is the equation for resistivity. We can write the equation for conductivity. What is conductivity? Conductivity rho equals, sigma equals 1 by rho. So sigma equals, you take the reciprocal of rho, N E square tau by M. So resistivity, conductivity equation is N is square tau by M. Now we define another quantity, mobility. Mobility. Mobility we denote by the letter mu. The drift magnitude of drift velocity per unit electric field is known as mobility. Mobility of electrons. Mobility is defined as the magnitude of drift velocity per unit electric field. Per unit electric field. Okay, so mu is equal to modulus of drift velocity, magnitude, by E. And what is the equation for drift velocity? Drift velocity equation is minus E divided by M into tau. So what will be the mobility? Mu equals E tau M by E. You can cancel this E. So what we can write? E tau by M. So this is the equation for the mobility, E tau by M. What will be is SI unit of mobility is meter square per volt second. This is the equation for mobility. It is important. Short answer can be asked. Define mobility, write its SI unit. Mobility is the magnitude of drift velocity per unit electric field. SI unit is meter square per volt second. So we obtained the equation for resistivity. What was the equation for resistivity? Rho equals M divided by N E square tau. Rho divided by M rho equals M by N E square tau. Okay, we can explain temperature dependence of resistivity. Now, next topic is temperature dependence on resistivity. Temperature dependence on resistivity. We consider metals. You know, for metals, resistivity increases with the increase in temperature. Resistance also increases with increase in temperature. We can explain it using the above equation. So, what is the equation for resistivity? Rho equals ML. Rho, what was the equation for rho? M divided by Ne square tau. So this resistivity is inversely proportional to tau, this relaxation time. When a metal is heated, the electrons gain kinetic energy. So they collide more frequently. So relaxation time decreases. So when a metal is heated, relaxation time decreases because kinetic energy of the electrons increases. Collisions become more faster, frequent. So what happens? relaxation time decreases. If relaxation time decreases, according to this equation, resistivity increases. So resistivity of metals increases with the temperature, increase in temperature. Increases with the increase in temperature. Resistivity, this variation with the temperature can be explained using another equation. We can use this equation also. R equals rho rho 0 into 1 plus alpha T minus T0, where rho is the resistivity at a temperature T Celsius. T degrees Celsius. Rho 0 is the resistivity at a temperature T0 Celsius. Rho 0 is resistivity at a temperature T0 degrees Celsius. Alpha is a constant known as temperature coefficient of resistivity. Alpha is constant. For different materials, it is different. For a given material, it is constant. It is also depending on temperature. Its value depends on temperature. So alpha is temperature coefficient of resistivity. So here also, as temperature increases, resistivity increases. We can write the equation for temperature coefficient of resistivity. You rearrange this equation. Rho equals rho 0 plus rho 0 alpha T minus T0. So we can write alpha as rho minus rho 0 divided by rho 0 alpha, rho 0 into T minus T0. Temperature coefficient of resistivity. This temperature coefficient of resistivity can be both positive and negative. For metals, it is positive. For semiconductors, it is negative. We can write the equation for resistance also in the similar way. R equals R0 1 plus alpha T minus T0. So resistivity or resistance of metals is increasing with increase of temperature. We can plot the graph like this. Take resistivity y-axis, temperature x-axis. The graph will be like this. It will be an increasing graph like this for metals. Now let us see for alloys. You know alloys. For alloys, there is no much variation of resistivity with the temperature. So resistivity of alloys, there is no appreciable change with the temperature. But the graph, we have drawn a straight line. It increases only, but small amount. Resistivity and temperature. So for alloys, there is no appreciable change in resistivity with increase of temperature. This is the reason why we use alloys for making standard resistors and coils of heating appliances. Now we discuss for insulators and semiconductors. We can use this equation. R equals m by n is square tau. For semiconductors and insulators, this n is number density of electrons per unit volume, number of electrons per unit volume. For semiconductors and insulators, this n increases with the temperature. The relaxation time decrease with the temperature. Relaxation time decrease with the temperature because electrons are gaining more kinetic energy. But here, the increase of n is very large compared to the decrease of tau. So tau has negligible effect. As a result, resistivity of semiconductors and insulators decreases with increase of temperature. So for semiconductors and insulators, n increases with increase of temperature. Relaxation time also decreases. So resistivity should increase, right? But effect of n, increase of n is much larger than the decrease of relaxation time. Relaxation time has negligible effect. Therefore, for insulators and semiconductors, resistivity decreases with increase of temperature. So if you plot a graph, it will be a decreasing graph. Resistivity, temperature, it is a decreasing graph like this. Okay. So resistivity of metals increases with increase of temperature. Resistivity of semiconductor and insulators decreases with the temperature. Okay, dear students, I will end the class now. Thank you for watching. Share, subscribe. All the best. Goodbye.